So we've had a look at silica content and textural differences to determine the basic classifications of an igneous rock. Is it felsic or mafic? Is it volcanic or plutonic? But how do you actually identify if an igneous rock is a granite, tonalite, or syenite? How does gabbro differ from diorite? Where the hell does iolite fit in? It all comes down to the mineral composition. So 1, you have to be able to ID the minerals, and 2, you have to work out the quantity of each mineral present. Simple, right? It is easier with plutonic rocks because you can see the minerals, but some minerals do look alike or aren't as common, so you may need to whip out a microscope, some very fancy lab equipment, or find someone who just so happens to be able to identify those minerals. If you can get a solid idea of the mineral composition, you can then pull out the infamous QAPF diagram. It may look a bit complicated, but it's actually pretty straightforward. Q stands for quartz, A stands for alkali feldspars, P stands for plagioclase feldspars, and F stands for feldspathoids. A feldspathoid being minerals that are similar to feldspars but have much less silica and a very different structure. Examples would be sodalite and nepheline. Each of the points represents 100% of the respective mineral, which then decreases in amount until it hits 0. So if we have a rock that has a high percentage of quartz and plagioclase feldspars, no feldspathoids, and very little to no alkali feldspars, it would sit over this side of the diagram. Then we would have to determine the ratio of quartz to plagioclase feldspars and the amount of mafic minerals to determine exactly what rock we're looking at. Granite pretty much makes up this area, so you would be looking at a higher alkali to plagioclase feldspar ratio, anywhere between 60 to 20% quartz and 0 feldspathoids. Diorite and gabbro pretty much occupy this same space, and the main difference is the amount of mafic minerals and plagioclase, with gabbro always having a higher percentage of plagioclase feldspars. Oh, and iolite contains a high amount of nepheline, so it goes here. Obviously, specific IDs really only count if you're doing research on a particular area or rock formation. For the casual rock lover, these can just be gabbro or diorite, and granite will pretty much cover most of these rocks. Not many people are going to pull you up on Monzo granite versus cyanogranite, though please let me know if anyone ever does. Now let's discuss mafic minerals for a moment. The QAPF diagram is only for plutonic rocks that have less than 90% mafic minerals. If we have a rock that has greater than 90% mafic minerals, we have entered the realm of ultramafic igneous rocks and have to turn to a graph like this. Here we are looking at the olivine to pyroxene ratio, or the olivine, pyroxene and hornblende ratio. But again, the specific rock names are really only for researchers. Peridotite and other general names are fine. And that's it for the basics of IDing plutonic rocks. Will there be exceptions to the rules? Always. Will there be debates about the specific type of rock in an area? Absolutely. And if you've been sitting here wondering how are you supposed to be able to identify all these minerals in the first place, you'd be asking a good question. I'll be doing videos on different rocks and mineral groups which may or may not be helpful. It really does take exposure and practice to get an eye in for it, and some minerals are easier to ID than others. And I know plenty of geologists who have had zero clue what we were looking at in the field.